This will be a review and breakdown of the Digitrax UP6Z and how voltage reduction is a vital component of your Z-scale railroad. So what am I talking about when I'm talking about Z-scale and voltage reduction? The motors in Z-scale locomotives have a lower maximum voltage compared to other scales. Z-scale locomotives can only handle somewhere between 8 and 10 volts maximum before the motor starts taking damage and will burn out. Typical DCC and DC control systems either don't have adjustable voltage maximums or don't have a setup that's low enough for Z-scale. If you directly use either of these systems on your Z-scale layout, you'd almost immediately fry the motors in the locomotives. So this is where a voltage reducer comes in. Let's take the Digitrax Zephyr for example. So the Zephyr puts out 13.8 volts. So what happens is you route your output of the Zephyr through the UP6Z, and that takes it down to a safe voltage for Z-scale, which is under 10 volts. All right. So what's in this unit? What's so special about the unit? So I have one here apart, just in case it snaps off. It's real easy. So I firstly want to say, yes, it's deceptively large. There's really not a lot inside the box, but it's not a bad thing. Digitrax reuses their standard case mold and associated ports from another similar device. That's the reason for all these extra ports and even the dummy power port that doesn't do anything. It's just filling the holes on the case. This isn't a bad thing, keeps the price down. Keep in mind that this unit is only $29 retail, so it is a big chunky looking device. It doesn't need to be so big, but it's a kind of a common size device for their inventory. Saves them money to put it in this kind of case. So what's important in this unit? So it's the set of diodes in the middle. So all these diodes have a voltage drop. So the idea is to chain a set of these diodes together to get the voltage down to what you want. So the diodes in the UP6Z are in blocks of 4, and each block has 2 sets of diodes. So the line comes in here and it goes between these two. If you're running DCC, it is an alternating current, so you need a diode that faces each direction in this current. So each of these blocks has one of these, it loops around, and it has another set of these. Each one of these diode sets reduces by about a volt. It varies by the type of diode you have, but for what Digitrax is using, it's about a volt. So it comes in here, reduces a volt, comes back around, reduces another volt. It says 2 volts reduction. There are 2 possible connection points here. One connection point routes you across, routes one side of the circuit across these 4, routes the other circuit across these 4. That gives you 2 volts, 2 volts, 4 volt reduction. There's another screw terminal here for 6 volt reduction, and that routes an additional block into the circuit, so you have 6 volts of reduction. So this is maybe a little confusing to look at, so I've actually put together a really simple paintbrush. I did this in Paint, but it's just a simple diagram. So here's the chain of diodes, and any of these type of devices that use diodes, they all work basically the same way. The voltage comes in, say this is a pair of wire here. The voltage comes in at, let's say, 13 volts. Each one of these diodes, one faces this way, one faces that way. The current comes through regardless of the polarity, but it drops a volt because it goes through one of these two. One of these two drops it by a volt. So you go 13 to 12, 12 to 11, 11 to 10, 10 to 9. So you basically want to take your circuit on wherever the voltage is correct. So with this unit here, if you put in 13 volts, you should get out approximately 9 volts. If you're doing a DIY route on these, which you can, it is possible to do, but keep in mind different types of diodes have different voltage drop. I think it's called forward voltage. I'm not sure on my terminology here, but they basically drop a different amount of voltage for the different materials they may be made out of, and they also, some diodes do vary on their drop according to amperage. So you'll need to look into the specs of what you're building, but this is the basic idea of the circuit. So I hope that gives you a general idea of what's going on here. It is fairly simple to use a standard DC pack or DCC system with Z-scale. You just need the right voltage reduction device. So hope you enjoyed this video, and happy railroading, everyone.